All right, so let's discuss the exact reasoning behind what electrical resistance is. Electrical resistance is one of the most interesting topics in the study of circuits and electrical physics. Now, resistance itself is a word that can kind of make us understand what it is in terms of physics. We know that resistance is basically whenever there's a kind of a force that disallows us to do something. Like when there's a force, when we want to do a piece of homework or a piece of practice or when you want to work out, there's always this resistance that doesn't allow you to get up and do the work. Now, in electrical circuits, resistors usually come in the form of anything that can convert electricity to, anything that converts electricity to heat as well as light. Basically, anything that can take away the energy of the circuit. So, anything that takes away the electrical energy and converts it to heat and light can be counted as an electrical resistance. But also, anything that can resist the electrical current to pass can also be thought of electrical resistance. I obviously standing for the electrical current circuit. So that's when I said resist the electrical I mean the resisting the electrical current. Now, resistors are generally used to control the current. So the current can actually become too high at times, and by using electrical resistance, we can control the circuit. So they're used to also control the current resistors. The electrical symbol for resistors in some books is a rectangular box that kind of looks like this. It's kind of outdated, but it is used nonetheless. Another symbol is a type of symbol which looks like the zigzag symbol, and it kind of looks like that. So this is the symbol for electrical resistance. Now, one of the main topics that is discussed in the study of electricity is the resistance that exists in a wire. The resistance of a wire depends on four things. We're not going to talk about the equation behind that resistance of the wire. We're just going to give an introductory information on it. But basically, four factors can determine the resistance of a wire. The first one is the length of a wire. Now, imagine you have a very long wire. You go all around your house and you try to charge your phone with that wire. Of course, a lot of energy is going to be dissipated because it's unnecessary to have such a long wire for such a simple purpose. So by increasing the length of a wire, you can actually increase the resistance. The second thing is the diameter or the thickness of a wire. It turns out by having a higher thickness, electrons are able to pass through easier, and thus resistance actually increases. So basically by having a higher thickness, the resistance goes down because electrons are able to flow or go through easier. However, if the wire is too thin or narrow, that means it's not very thick, then the resistance actually increases because it's more difficult for the electrons to flow through. Thirdly, of course, certain materials can have different types of resistivities. For example, materials that are generally insulators have very high levels of resistivity, things like wood and plastic, whereas things like copper or silver are some of the best conductors that we know of. So it also depends on the material. The fourth thing is the temperature, which we're going to kind of summarize it and just say that if temperature increases, the resistance also increases. And you can think about it in terms of the chaos that happens within material forms inside the electrons, and their collisions kind of increase, and as a result, the resistance also increases because it's more difficult for them to flow through. Now, we use a special equation, a very simple one, at the IGCSE level to calculate the resistance in a specific wire with current and voltage, and that is known as Ohm's law. Ohm's law states that resistance is inversely proportional to the current, but directly proportional to the voltage. So R is equal to V over I. So what does this law really state? It says that voltage across current will remain constant as long as the temperature does not change. We know that V is the voltage measured in volts, I is the current, which is measured in amperes, and R is the resistance or electrical resistance measured in ohms. And that symbol is actually a Greek symbol which stands for omega, and the unit of omega, however, for electrical resistance is read as ohms. So current is simply directly proportional to the potential difference at the constant temperature. Now, one simple question would be something like, what is the resistance if the current is 25 amperes and it is connected to a 200 volt battery? So resistance is going to be 25, so it's going to be 200 volts divided by the 25 ampere. So 200 divided by 25 would simply give us 8 ohms, and that would be the answer. Now, typically we use sometimes units like milliamperes, or actually for voltage, volts is usually used, but milliamperes is a common unit that is used for current, and you should be familiarized with it. Milli stands for 10 to the power of -3. So 10 milliamperes would be 10 times 10 to the power of -3 amperes. 20 milliamperes would simply be 20 times 10 to the power of -3 amperes. That's about it. Thank you for watching.